All right, you have made it to the last chapter, one lesson. This is called direct variation. It is lesson 9, and I do need to warn you, there's some pretty intense vocab in this lesson, okay? But here's the moral of the story. This is all about proportional relationships, okay? This is all about testing for a proportion. It's all about the unit rate on this one, okay? Just remember that. Keep that in your mind as we go. So we're going to start off with some vocab. And I've thinned this out to be the last 2 vocab words that we have in the entire chapter, and the first one is direct variation. And a direct variation is a proportional relationship. Okay, so remember what I said at the very beginning of this video. It's all about the proportion. So we need a proportion for a direct variation. Okay, it's a proportional relationship. Here's where it gets pretty mathematical, in which the ratio of y to x is a constant k. You want to know what that means? That means that when we find our unit rates, they're all the same, which is what our proportional relationship is, and that unit rate is going to be called k. Okay? The direct variation has an equation that goes along with it because it's all with tying the graph together with the table, together with the word problems, together with the unit rates. And this equation is y equals kx. Okay? Y and x are going to be the x and y values that we plot in our graph, right? Those values come from the table. And this k here is that unit rate. Okay, here they're calling it a constant ratio, but it's just the unit rate for the table. Okay, so remember this equation, y equals kx. Put this on your direct variation vocab card. Last word, and this is the biggie, it is called the constant of proportionality. And you know what that is? That's just the constant ratio. That's just the unit rate. That's just that letter K in the direct variation. So constant of proportionality, all it is a fancy name for the unit rate that we get from a table when we solve all of our unit rates to prove that we have a proportion. All right? So 2 pretty big vocab words, but it's tying everything together. It's tying together the tables, the unit rates, the equation, the graph. Everything here is tied together with this equation, y equals kx, this idea of the constant of proportionality, which is that unit rate. We call it k. All right, so don't get too nuts about this. It's all good, pretty easy stuff. So, notes, there's a lot of repetition in these notes. I am going to warn you now. I'm just going to type along as we go here. Direct variation is a proportional relationship, just like we put down in our notes, in which the ratio of y to x is a constant, and we call that constant the variable k. Okay? The equation for a direct variation, we already wrote this down as well, is y equals kx. Okay, we already talked about that. K is, remember that other term we just talked about? K is what we call the constant of proportionality. That's it. K is the constant of proportionality. And we just have to talk about the fact that the constant of proportionality has another name, and that secondary name is called the slope. So think of direct variation as taking every single lesson from chapter 1 and trying to tie it all together in a bundle. And this is it. Okay? Let's do a problem. Oh, I forgot I added this slide. There are a bunch of different ways to find the constant of proportionality, okay? And you may be asked to find the constant of proportionality for a variety of different problems, and here is my cheat sheet for that, okay? So my cheat sheet is, if you are given a table and asked to find the constant of proportionality, just find the unit rate of every xy pair. All right, no deltas here. You didn't hear me say delta. I'm only saying it, telling you not to do it. You just go y over x, find the unit rate. Y over x, find the unit rate. Y over x, find the unit rate. If you're given a graph and asked to find the constant of proportionality, just find the slope of the line. You know how to find that, but we can only find that slope if the graph is a proportional graph. If it's not proportional, there is no constant of proportionality, right? If you are given an equation, okay, if you're given an equation, it's just the number in front of the x. That's the constant of proportionality. And if you're given a word problem, well, now you have to either create a table, create a graph, or create an equation, and then follow one of these steps above based on what you created. All right, this is a very important slide right here. I would like you to star it. Make sure you understand these notes are very important because this tells you how to find the constant of proportionality no matter what type of question you are given. All right? Now we've got some questions to look at. Here's our first one. 2 minutes into his run, Brandon has traveled 400 yards. After 5 minutes, he has traveled 1,000 yards. Is this a direct variation? If so, find the constant of proportionality and write the direct variation equation. This looks like a pretty intense problem. It's not. All it's asking when it says, is this a direct variation? They're asking if it's proportional. Are the yards proportional to the number of minutes he's been running? We'll find out, okay? So here's what we're going to do. We're going to create a little table, and in our table, we've got minutes and yards. And we only have 2 little pieces of information in the table because they only gave us 2 pieces of information in the problem. After 2 minutes, Brandon has traveled 400 yards. After 5 minutes, he has traveled 1,000 yards. So, let's go back to our previous slide. How to find the constant of proportionality. Well, this was a word problem and we chose to make a table. So if we're trying to find the constant of proportionality from a table, first we have to find those unit rates and see if it's a proportional relationship. So to find the unit rates, we take 400 yards per 2 minutes. Remember, money in the top, time in the bottom. 400 yards per 2 minutes. And we're going to find the unit rate. So we're going to divide by 2. When we do that, we get 200 yards per 1 minute. Now remember, for this to be a direct variation, this second combination of minutes and yards has to simplify to the same unit rate. So let's hope it does. 1,000 yards per 5 minutes. Okay, so we're going to change that to a unit rate as well. We're going to divide by 5 this time to turn the denominator into a 1. And when we do that, we get, guess what? We get 200 yards per minute. So, lucky for us, these 2 unit rates are the same. That tells us this is a proportional relationship, which means yes, it is a direct variation. Okay, yes, it is a direct variation because the unit rates are the same. So now we have to find the constant of proportionality. Well, guess what? We already did. This unit rate is the constant of proportionality. So the constant of proportionality, we're going to call it K. Remember, they called it K in the vocab. The constant of proportionality is the numerator of the unit rate. It is 200. We don't need yards, we don't need minutes, we don't need the 1, we just need the numerator, 200. And then it asks us to write the direct variation equation. Well, this is very easy as well. Remember in their notes, the equation is y equals kx. So our job is to put 200 in place of the k. So the direct variation equation is y equals 200x. That's it, my friends. That's as hard as this is. That's it. It sounds complicated. It's a lot of pretty intense vocab, but it's really just about finding everything we've already found so far in this chapter. I do want to show you another example. I want to show you an example where they start us off with an equation this time. So this time, they give us an equation. The equation is y equals 12x. Okay? So y equals 12x represents the amount of money, y, James earns for X hours of shoveling snow. Identify the constant of proportionality. So first we want to figure out what K is. Let's go back to our notes here. It says if you are given an equation, that's what we're given this time, it's the number in front of the X. Remember, the equation is y equals Kx. So K is the constant of proportionality. All we have to do here is take the number in front of the X, and that is our constant of proportionality, K. K equals 12. That's not a pretty 2, but you get the point. Let's try that again. K equals 12. 12 is the constant of proportionality. We're halfway done this problem. Now it says explain what it means in the situation. So this is a little bit tricky. Remember, K is a unit rate. K is a unit rate. So we have to put that 12 back into unit rate form now. K is 12. If we want to talk about the unit rate, it's 12 over 1. And it tells us that it's the amount of money that James earns for X hours of shoveling snow. So it's $12 that James earns for every 1 hour of shoveling snow. So if we want to explain what this constant of proportionality means, we have to use our proportion, ratio, rate language, and we say for every 1 hour, James earns $12. Remember, we always start with the denominator first because that's our unit rate. For every 1 hour James shovels snow, he earns $12. There's our explanation. So we had to do two things in this problem. Did we do them both? Did we identify the constant of proportionality, K? We sure did. It was 12. Did we explain what it means? Well, that took a little bit of work. We had to first change it into a unit rate and match it up with the units in the problem. And then we could do our explanation right here. I have one more. Use the direct variation equation in example number 2 to determine the amount of money James will earn if he shovels snow for 15 hours. So remember, X, our denominator unit, is hours. Our numerator unit is dollars. So here we're going to put 15 hours into our equation, and that was our X number here. So if we want to know how much James earns if he shovels snow for 15 hours, we put 15 in for X. And we solve for Y. So Y equals 12 times 15. 12 times 15 is 180. Remember, Y was the amount of money he would earn. So James will earn $180 if he shovels snow for 15 hours. James will earn $180. That's it. That's all. Students get really bent out of shape over direct variation because of the vocab. Please don't. Pay attention to this slide right here. This is the key. It tells you how to solve for the constant of proportionality, no matter which type of problem they give you. If it asks, is this a direct variation? All you have to do is figure out if it's proportional or not. So you have all the tools in your toolbox right now, guys. All you have to do is put them all together to finish up this chapter. Update your vocab. Definitely make note of how important these notes are right here. And let's ask any questions you may have tomorrow in class. Don't forget to do your practice problems. Start studying for your test.